All right, and so then there's angular damping, and angular damping says that when a body is rotating, that if there is any angular damping, it should start to slow down and stop rotating. It will not affect the linear motion of the body. So we can experiment with that in a moment too. And then, as we talked about last week, I set is sleeping allowed to false because I knew that in this example that people would be flipping the gravity on and off. And if the body was allowed to sleep, when you turned on gravity, it would not fall. So, for example, if we set this to true, we reload it, and wait a moment, and what's happening here is we cannot see it, but what happens is the body is going to sleep. We click on gravity, it turns on gravity, but because the body is basically sleeping, the physics engine is ignoring it. It's not going to drop until it's interacted with, and because we can't touch it, it doesn't have any dragging capabilities, it's never going to wake up. So I set is sleeping to false, and now it will fall under gravity. Okay, so this is just giving us something to attach our limbs to. Again, a ragdoll is to me nothing more than some kind of body with one or more segments and then limbs attached to it that flop around, and they don't have any limitations on their angle, which not necessarily true. You could change that, but in this case, I'm not putting any limits on the rotational angle of the limbs. And that's pretty much it. So let's go ahead and put a head on the doll. Head is nothing more than a marker in this case to make it seem more like a rag doll or a doll. And this head is attached to the body with a weld joint. If I turn on hybrid mode, you'll be able to see, I'm not sure if you can see it well in the video, vaguely you'll see a line between the head and the body, which is telling us that this is a joint connection and that it is connected to the body. We can't see it yet because I can't move it, but if I were to move the body, turn on gravity for example, the head will stay oriented with the body no matter how it turns or moves. Now it's worth noting that a weld joint is not a guarantee of exact distance over time. You can't rely on any of the joints to be precise. The precision of a joint in the game depends on how well the physics engine can handle the calculations it has to achieve within a set time. So what can occur is if you have a very complicated body or a large number of physics bodies with lots of different joints, you can start to see body parts pulling apart or joints starting to separate. If you see that in your game, what's actually occurring is the physics engine is no longer able to keep up with all the work it's supposed to do on a frame-to-frame basis. And so you either need to simplify your game by reducing the number of bodies and joints, or you need to increase the time that the physics engine is allowed to do its work. And so at the beginning of the show I said we can talk about setting velocity iterations, etc., etc. This is the kind of thing that we would talk about later, and then hopefully I can give some examples of how these things are not behaving properly, and then we can fix them with the features in the physics engine. But I just wanted to point out that people should be aware that joints are not perfect, and so when we get to the car example, you'll see that the car hits the ground and the tire moves a little bit. That might be unexpected to people who don't know what's going on, but that's just the way the engine works. It's not going to be exactly precise 100% of the time. All right, so let's do an arm, and having done one arm, we'll do a leg, and that will pretty much lay out the groundwork for people to understand what's going on here. So let me turn on the arm code. Okay, let me turn off hybrid because that's a little bit distracting. Turned on the whole body, but that's fine. Okay, so the way this arm code works in a nutshell is I have a builder function. It lays out one segment of the arm, and the horizontal bits of the arm and the vertical bits are the legs. And there's a builder function for legs and a builder function for arms. It's worth noting at this point that this is sort of like the traditional layout for a body that you see in graphics programs, either 3D or 2D, sort of like the default pose. And I'm not an artist, so I won't go into I'm sure there's many reasons why people do this, but for me, the reason I laid this out is because it makes the math simple. I can say that I want my arm to be relative to the center of the body, this high off the belly button if you want, and then so far to the right or left, and it just makes it easy to lay out. Now, if I had tried to lay out the arm at an angle like this, then I would have to calculate. Calculating this joint is easy because I know that the body is here and I can just go up and to the right. But then calculating this arm segment's X position relative to the arm, I'd have to do 2D math. I didn't want to do that. Now I'm really doing 2D math when I do this pose, but the 2D math is quite simple. It's just add a certain Y element, add a certain X element, you're in the right place. It's easy to measure, it's easy to calculate, nothing to it. So that's the reason we're doing this pose, and that allowed me to create a generic arm builder, which always creates a horizontal segment, and a generic leg builder, which always creates a vertical segment. So when I create the right arm, let's find it again. If the right arm code is enabled, which it is, I call the create arm segment function, and it passes back one element, which is the rectangle, and I store it as the right bicep. It passes back a marker, which is this marker here, with the one that's now grayed out, and I store it as temporary because I'm knowing I'm going to get rid of it. And it passes back another marker, which I store as the right shoulder marker. I don't know why I did that. Oh, I'm sorry. The first marker it passes back is on the right. The second marker it passes back on the left. So, for example, when I create the left forearm, the first marker that passes back is where this red one is, and the second one is this green dot. So, first marker is the rightmost. Second marker is the leftmost marker. This function here, create arm segment, basically I pass in a display group to store everything in, and then an X and a Y position, and that is telling the function place the arm center. I don't know why George did that. George just got a twitch. Place the arm segment right here, the center of it right there. Place this arm segment right here. It's basically saying where to place the center of the object. Arms twitching. All right. The other thing I tell it is how long to make the arm, and how thick to make it, and then what the turn radius is on the arm. And what that does, it's used in the rounded rectangle to choose the rounding for the corner.